नमस्कार बच्चों, मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री का लेसन ऑन ऑर्गेनिक केमिस्ट्री. Okay, IUPAC nomenclature. Now in today's lesson we will be learning the IUPAC naming of some complex substances, complex substituents. Okay, so what are these complex substituents? I've just taken an example where there is a straight chain, and here you can see some branched substituent. Okay, and this branch substituent is itself branched. Okay, so this is the straight chain. This is the longest straight chain, and this is the substituent. Now this is a substituent, yes, but this is also called as a complex substituent because this is itself branched. Okay, why I call it as branched, I'll just tell you now. First, let's number the longest chain. So if I number it from here, 1, 2, 3, 4, 5, 6, 7. Yes, so this is the longest chain, no other way, because if I number it this way, 1, 2, 3, 4, no, it is not giving me a long chain. Now, if I number it from here, 1, 2, 3, 4, 5, 6, 7. Now, according to the blue numbering, a substituent is getting the second position, right? And according to the red numbering, it is giving me 6th position. So I'm not going with the red numbering. I'll go with the blue numbering. Okay. Now, this substituent, here there is a rule that the carbon atom, that is, this is the carbon atom that is for the substituent. I'm talking about the substituent. For the substituent, assign first number to the carbon that is directly attached to the main chain. And then follow the IUPAC name. Okay, IUPAC for substituent. Okay, and for substituent, because it is complex, it is always written in bracket. So it is written in bracket. We will take an example now, don't worry. Okay, now here. Over here, if I number it, so this is the carbon that is attached directly. So I have to give this number 1. Okay. So the carbon that is attached to the main chain, that is always given assigned a number 1. Okay, I cannot assign number 1, number 2, number 3, saying that this is the longest chain. No, this is wrong. So I always have to assign the carbon that is attached to the main chain as number 1, and then this you can write it as number 2, or you can also give this number to, in either way you can do it. Okay, so this has become substituent within the substituent. Okay, that is why I call it as complex substituent. So it is already a substituent, and there is again a substituent methyl group within that substituent. So it is called a complex substituent. Okay, in some books they number this as dash because this is the numbering of the substituent. So in order to reduce the confusion. Okay, either way you can do it, no problem. So what is the name of this compound? Okay, so we have at the second position, what do we have? Second position, we have the complex substituent. And how is the complex substituent? How do we name the complex substituent? 1 dash. At 1 dash, what is there? Methyl is the substituent. Yes. And we have numbered 2 carbon atoms. So it is ethane group, yes. But because it's a substituent, we don't use ethane, we use ethyl, because it is, this whole thing is a substituent after all. And then we name the root word. What is the root word? Hept. There's no double or single bond, a double or triple bond, so heptane. So always, how is the order? We name the substituent, then we use the root word, and then we use the suffix. So this was done many times in my previous videos. So this is the substituent with the position, and root word. Okay, there's no suffix, there's no triple or double bond. Okay, so this is how you name it. Okay, so you can also avoid this dash. Okay, you can just write it as 1 also, no problem. I hope I'm clear. Okay. Moving on further. If I give this kind of a substance, okay, so CH3, CH2, 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 2 valencies are satisfied, 2 more needed. Here I have a substituent. This is CH, this is CH2, 2 valencies satisfied, 2 more needed, 2 valencies satisfied, 2 more needed, 2 valencies satisfied, 2 more needed, 1 valency satisfied, 3 more needed. Then here I have a okay. So this hydrogen I'm placing it here. Okay. Now over here, if you number it, if I'm numbering it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So if I number it in any other way, 1, 2, 3, 4, 5, 6, 7, 8. No. So first rule is always number the longest chain or select the longest chain. So which I have done. Okay. Next is this whole thing is the substituent. This is the substituent, and it is a complex substituent. As you can see, there are a lot of branches over here, right? You cannot give a straight chain numbering over here if you just observe. Okay, anyway, let's check it. Okay, so this is the substituent. Okay, let's number it. If we number it, always the carbon that is attached to the main chain is given number 1. So I put it as 1 dash. You can just put it as 1, no problem. 2 dash. And you can put this at 3 dash or put this as 3 dash. Anyway, either way you can do it. Okay. Now you can see over here, this is our branching over here. This is our branching. So we call this as complex substituent. Just to identify, I'm just explaining this, that it's a complex substituent. Okay, coming to the naming, always we write the name of the substituent first with the position, then word root, and then suffix if there is a double or triple bond present. Okay, at what position is the attachment? At the fifth position. Oh, we didn't check from the reverse order. I think from the reverse order also it would be the same. Anyway, let's 1, 2, 3, 4, 5, 6. Oh, the attachment is from the sixth position, so we won't use this numbering. We will use the red numbering. Okay, at the fifth position, the attachment is there or the substituent is there. Okay, and what is the name of the substituent? That is also branched. So at 1 dash and 2 dash, we have methyl groups. So 2 methyl groups are there. So 1 dash 2 dash dimethyl. And in the substituent, what is the how many carbon atoms are there? 3 carbon atoms. So it should be propane, but because it's a substituent, we call it as propyl. Close the bracket. Okay, and now coming to the root word, that is the main chain, that is having 10 carbon atoms. So decane, there's no double or triple bond. So it's decane. Okay, and complex substituent are always written within the bracket. Okay, I hope I'm clear here. Needed, 3 valency satisfied, 1 more needed, 2 valency satisfied, 2 more needed, 2 valency satisfied, 2 more needed, 1 valency satisfied, 3 more needed, 2 valency satisfied, 2 more needed, 3 valency satisfied, 1 more needed, 1 valency satisfied, 3 more needed, 1 valency satisfied, 3 more needed. Okay, now coming to the numbering of the longest chain, we always select the longest chain first. So 1, 2, 3, 4, 5, 6. Okay. Now, if I can, let me check if I can do the numbering in some other way. 1, 2, 3, 4, 5, 6. Okay, students, this is the next question. Okay, now if I'm numbering 1, 2, 3, 4, 5, 6. Okay, if I number it in any other way, 1, 2, 3, 4, 5. So I'm getting only 5. So here I'm getting the longest chain. Okay, now this is our substituent. Okay, so this is our substituent now. Okay, so this substituent, we have to number the substituent now. Okay, the rule is the carbon that is attached to the main chain is always given number 1. So here also, if I'm giving this number 2, this is number 3 dash. Okay. Now, here I'm getting again a substituent within the substituent. So definitely this is a complex substance. So the attachment is at the second position. So at 1 dash, there is a methyl group. And so here we are naming the substituent. So there are 3 carbons. So not propane, but propyl, because this is a substituent. I close the bracket. And then what is the root word? Hexane. Okay. So I hope you got an idea how to name and number the complex substituent. Okay. Now 1, 2, 3, 6, 7, 8. Okay, here I have CH, CH3, CH3. Okay, CH3, 2 valencies are satisfied, 2 more needed, 2 more needed here. 3 valencies are satisfied, 1 more. 2 valencies are needed, 2 valencies needed, 2 valencies needed, and this is 3 valencies needed. Okay, now numbering it 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is our substituent. This is our substituent. So if I give 1 dash, because the carbon that is attached to the main chain is given number 1. So that students, the carbon that is directly attached to the main chain is given number 1. So I have given 1 dash. Okay. So the methyl, this methyl will become 2 dash, or you can make this as 2 dash. Okay. Any one of them. Anyway, one of the methyl group will become the branching. That's why it's called a complex substituent. Now, how will you name it? So first, the substituent. Substituent is at what position? The 4th position. 4. At the 4th position, what is the name of the complex substituent? At 1 dash, I have a methyl group attached. And there are 2 carbon atoms. So I'm talking about the substituent. In the bracket, always the substituent. In the bracket, always the complex substituent. So there are 2 carbon atoms, so it is ethane, but it is a substituent. That is why it is called ethyl. And then root word, there are 8 carbon atoms. So octane, there is no double or triple bond. So simple tane. Okay. I hope, student, you got an idea how to write the name of the substituent, numbering of the substituent. Okay. Now drawing a bond line structure now. Okay. And right. Now this is all these edges are all carbon atom. Okay, it was done in the previous videos also. A lot of bond line structures were drawn in the previous videos. So all these edges were carbon atom. So this is 1 carbon atom, 1 valency satisfied, so 3 hydrogens. This is carbon, 2 valency satisfied, 2 hydrogens. This is carbon, 2 valency satisfied, 2 hydrogens. 2 valency satisfied, 2 hydrogen, 1 valency satisfied, so 3 valency satisfied, so 1 hydrogen, 2 valency satisfied, 2 hydrogens, 2 valency satisfied, 2 hydrogens, 2 valency satisfied, 2 hydrogen, 1 valency satisfied, so 3 hydrogens. Okay. Now over here also, all these are carbon atoms. So here there's a carbon, here there's a carbon. All in here there are carbons. So there are 2 valency satisfied, 2, 1, 2, 3, 4 valencies are satisfied. Here 2 valencies are satisfied to 2. 1 valency satisfied, 3 hydrogens. 1 valency satisfied, 3 hydrogen. 1 valency satisfied, 3 hydrogen. Okay. Now, this is our bond line structure. You don't have to fill in the CH2s and CH3s, etc., but just for your understanding. Okay. Now, coming to the numbering of the root word or the longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9.
So if we number it from the reverse order also, it is the substituent is coming at the 5th position. Okay. Now this is our substituent. This is our substituent. Now this substituent you can see. Okay, students. Now coming to the numbering of the substituent, always the carbon that is attached to the main chain will be given number 1. Okay, I cannot use this as number 1 to select the long chain. No, the carbon that is attached to the main chain is given number 1, then 2 dash, and then 3 dash. Okay, or I can also go this way, 2 dash and 3 dash. Anyway, both of them are giving me the same effect, giving the same effect of having branched chain. Okay, so we cannot avoid branching here. So this is the ethyl group, and this is the methyl group. So at the first position, I have ethyl group, and also at the first position, I have the methyl group. I'm talking about the substituent. Okay. Now, coming to naming, the attachment is at the 5th position. I mean, the substituent is at the 5th position. So 5. Now, bracket. This is ethyl, and this is methyl. Which one to name first? Always naming according to the alphabetical order. So at the first position, I have ethyl. At the first position, I also have methyl. In the substituent, how many carbon atoms are there? 3. So it's not propane, but it's propyl because it's also a substituent. And then root word, nonane, because 9 carbon and there's no triple or double bonds. Okay. I hope I'm clear. Now, students, let's take an example over here. Now, this is the main chain, 3, 4, 5, and this is the substituent. In the substituent, if we number the substituent, the carbon atom attached to the main chain is given number 1. Then this you can give number 2, or the methyl group down you can give as number 2. Anyway, it's fine. So the attachment is at the 3rd position, so 3. So first carbon atom of the substituent has a methyl group. It's methyl group, methyl, and there are 2 carbon atom in the substituent. So ethyl. Substituent name is over, close the bracket, and root name is pentane because there is no double or triple bond. Okay, now over here you can see this methyl ethyl, 1 dash methyl ethyl. Sometimes in some books they refer as iso group also. Okay, so this is the common name. Sometimes in books they refer 3-isopentane. Okay, so here we have to know the common names of some common names which are used in the books, because in the exam sometimes instead of writing the whole IUPAC name, they use common names sometimes. Okay, now one difference is that in IUPAC, okay, we count only the number of carbon in the main chain. Okay, but for common name, all the carbon atoms are counted. So this you have to keep in mind. So in IUPAC name, we count only the number of carbon atom in the main chain, how much we have numbered. Okay, in common name, we count all the carbon atoms. Okay, now some of the common names that you have to memorize is, okay, so these are few things that you have to memorize. So this is the substituent. So in common name, we count all the carbon atoms, okay? So IUPAC name and common name. Okay. Okay, students, let's see now some of the common names of some substituents and IUPAC names. Okay, so these common names are very important. Okay, suppose this is the main chain and there are two methyl groups attached. Okay, and definitely you have to number it for IUPAC. So this is 1 and this is 2. So here the name would be what? For IUPAC, 1-methyl. You have numbered 2 carbon atoms in the main chain, so it is ethyl. It's not ethane because it's not the main chain. We are talking about the substituent, so we write it as ethyl. Okay. Now the common name here, students, whenever there is one methyl group attached, okay, whenever there is one methyl group attached to the carbon atom connected to the main chain, okay, we call it as what? Iso. There's one more rule here. This is one rule. This is called as iso. And here in common name, we consider all the carbon atoms. Since there are 3 carbon atoms, we call it as propyl. Not propane, propyl, because it is a substituent. So first is when methyl group is attached to the carbon atom to which the main chain is connected. Okay, so it is called as isopropyl. Okay, so this is one of the rule. Okay. Second name or second substituent is CH2. So this is all the attachment, okay, to the main chain. CH2, CH3. So this is a straight chain you can see, okay, and here there are 3 carbon atoms. So definitely it is propyl, okay, and it's a straight chain, okay. So that is why it is called as normal propyl. Okay. Now this is the connection to the main chain. CH2, 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 CH3. So you can see there are 4 carbon atoms and it's also a straight chain. So it is called as butyl. And for common name, it is called normal butyl. Okay. Now, over here, I will make it branched. CH, 2, CH, CH3, and CH3. Okay. And for common name, for IUPAC name 1, 2, 3, this is 2-methyl propyl. We have numbered 3 carbon atoms, so this is propyl. Okay. Now here I have the methyl group connected to the second carbon atom, right? And also there is another methyl group from the main chain. Okay, so this is another rule for giving iso. The carbon is connected to methyl group as a branching and one methyl group from the main chain. Then also we call it as what? Iso. Okay, so that means there are 2 methyl group. One is from the branching and the other one is from the main chain. We call it still iso. One iso we saw was when there is 1 methyl group attached to the first carbon of the substituent. Okay, that is also a iso. And the second rule is that there are 2 methyl group attached to the carbon atom, and one is the branching and one is from the main group. So this is iso And in common name, we consider all the carbon atoms. So there are 4 carbon atoms, isobutyl. Okay, so these are the 2 ways. Okay, and I have another arrangement where now the difference will be clear. Here also I have 4 carbon atoms here, right? So can you see the difference between these two? Here there is, I'll just number it 1, 2, 3, right? Here there is a methyl group, okay? So if for this to be called as iso, there should be another methyl group next to this carbon atom in the main chain. But here we don't have a methyl group, we have a CH2. Okay, so we don't call this as iso group. Instead, we see it like this. If the carbon atom, this is a carbon atom connected to the main chain, right? It is the carbon atom connected to the main chain, has 2 surrounding carbon atom. Okay, it is called as secondary. It is called as secondary, 20, secondary. And how many carbon atoms are here in total? 4. So we call it as butyl. I hope you understood. So you can take it like this. For smaller chains, if the carbon atom attached to the main chain is directly has a methyl group, you call it as an iso. But for bigger chain, maybe for from butyl onwards, you can consider it like this. The carbon atom should have 2 methyl group, one in the branching and one in the main chain. Then you call it as iso. Okay, and then we call it as secondary butyl. If the carbon atom that is connected to the main chain has 2 surrounding carbon atom, we call it as secondary butyl. Okay, so we didn't do the IUPAC naming. IUPAC naming is 1-methyl propyl. Okay, so if it is 1-methyl propyl, it is a secondary butyl group. Okay, now coming to another branching. You can memorize it like this also. 1-methyl propyl is called secondary butyl, like that also. Either way, whichever you find it easier. Okay, so the naming is 1, 2, numbering, sorry. And this is 1, 1, the IUPAC name is 1, 1 dimethyl. Here we have numbered only 2 carbon atoms, so it is ethyl, 2 carbon atoms. Now, coming to the common name, whenever carbon atom that is connected to the main chain is surrounded by 3 carbon atoms. See, whether we have numbered it or not, it is surrounded by 3 carbon atoms. We call it as tertiary. And here, how many carbon atoms are there in total? 4 of them. So, butyl. They also call it in some books tertiary butyl. So secondary and tertiary, I hope you understood. When the carbon atom that is directly connected to the main chain is surrounded by 2 carbon atoms, we call it secondary. If the carbon atom connected to the main chain is surrounded by 3 carbon atoms, we call it as tertiary. Okay, and I hope you understood the iso one. Iso one, the iso group. How do you recognize? When the carbon atom is connected to 2 methyl groups for bigger chains, 2 methyl group, one from the branching and one from the main chain. Okay, one from the main chain, one from the branching, you call it as iso. For smaller chains, when the carbon atom connected to the main chain directly has a methyl group, we also call it as iso. Okay, now we have one more branching for 5 carbon atom. 1, 2, 3, 4, 5. So I hope you will put the hydrogens, fill in the hydrogens. 2, 2, 3. So this is 5 carbon atoms in one chain. So this is pentyl group. And this is straight chain, so normal, pentyl for common name. We can also make it in the form of branching, carbon, CH3, okay, so 1, 2, 3, 4. So at the second group, second position, we have 2-methyl, and how many carbon atoms are there? 4 carbon atoms, numbered 1, 2-methyl butyl, okay. Now here, this common name is, here also at the second position, there is a methyl group, so 2-methyl position. So this is also called as what? Isopropyl. Okay, so whenever there is a methyl group at the second position, you can call it as iso. Okay, and also the rest of it is a straight chain. So then also you can call it as a iso group. Okay, so here also in that case, here also we can that is also satisfied over here. Okay, here there is a methyl group at the second position and the rest of the group is straight. Then also you can call it as iso group. Okay, so this rule is satisfied here also. Okay, now coming to one more arrangement where this is the attachment to the straight chain. So I wanted to make it a bit bigger. So CH3, CH3, CH3. Okay, so numbering is 1, 2, 3. So this is 2,2-dimethyl propyl, right? For IUPAC naming. Okay, so if there is 2,2-dimethyl group, then it is called as neopentyl group because we consider all the carbon atom. Okay, so students, these common names you just have to memorize in case if it comes in the exam. Okay, the common name. Okay, you are able to answer the questions, right? Okay, now coming to some cyclic alkanes. Cyclic alkanes means where we have closed structures like this. These are closed structures and we draw it like this. These are called as closed structures. Okay, and when we name the IUPAC names, when we give the IUPAC name, we write down substituent. Okay, in substituent, we write whether it is nitro group, chloro group, bromo group, methyl group, etc. Then we write if cyclo group is there, we write cyclo. Then we write the word root. Then we write suffix, whether it is a double bond or triple bond or single bond. Okay, so this is how we go about. So for cyclic substance, we have to write down cyclo, okay, for the naming. Okay, similarly, if I have this type of a closed structure, this is 4 carbon atom and it is closed. We write it as cyclobutane. If there's a double or triple bond, we write butene or butyl, butane. Okay. Similarly, if I have this kind of a structure, this is 5. 1, 2, 3, 4, 5. Cyclopentane. 5 carbon atoms, right? 5 carbon atoms. Then we have there are 6 carbon atoms. 1, 2, 3, 4, 5, 6. Cyclohexane. This is not benzene, this is cyclohexane. Okay. And if I have a methyl group attached here, okay, what would be the name? So always this carbon I will give number 1, 2, 3, 4, 5, 6. So always the substituent name first and the position. Substituent is methyl at the first position. Okay. Then cyclo. After the substituent name, we use cyclo if it's a cyclic substance, cyclohexane. Okay. Similarly, CH2, CH2, CH3. Okay, so here this is the cyclic group. Okay. Here there is a straight chain and there is a cyclic or a ring substituent, right? So there is substituent or not, we have to check. Ring and there's a straight chain. Now, whom we would consider as the main chain. Now, who is the main chain here? Whether it's the ring or the straight chain, we use a rule which I said in my previous video also. We check if there is a functional group or not. This is the priority order, okay? Priority order. If there's no functional group, then look for double or triple bond. If there's no double or triple bond, check for the number of carbon atom, more carbon atom, more carbon atom. That will become the straight chain. So you will go with the priority order. If there's a functional group in that particular ring, it will become the main chain. Okay. If there is a double or triple bond, that particular ring or straight chain will become the main chain. If any of them has more number of carbon atom, that will become the main chain. But this is the priority order. First, go with the functional group. If that is not there, go with the double or triple bond. If that is not there, go with the number of carbon atoms. So here in this case, we don't have functional group. We don't have double or triple bond. We check the number of carbon atom. So here there are 4 carbon atom in the ring. Here there are only 3 carbon atoms. So definitely the ring has become our main chain. So we number it this way: 1, 2, 3, and 4. And straight chain, we number it. The carbon that is attached to the ring is given number 1, 2, 3. So how do we name it? I hope this part is clear. So I hope you have taken a note of this. Okay. So at the first position, we have propyl, because it's a straight chain, so nothing else to mention, propyl. Then here root word is butane. We use cyclo because this is cyclic substance. Okay. Now, if I have a compound like this, CH2, CH2, CH3. Now here, both of them have the straight chain has 3 carbon atom, the ring has 3 carbon atom. Both have 3 carbon atom. Right? It's a tie now. It's a tie now between the straight chain and the ring. It's a tie. In this case, in such cases, not in all cases, when there is a tie, there is nothing to compare. There's no functional group. Both of them have no functional group. Both of them have no double or triple bond, and they have equal number of carbon atom. So there's a tie. In that case, the ring is given more priority than straight chain. I said only in case of a tie, please. Okay. So in that case, what would happen? 1, 2, 3. So 1-propyl, cyclopropane. Only in case of a tie, not in all the cases, please. Okay, I hope I'm clear. Coming to the next one. This is CH3, CH3. Okay, here there's a carbon atom. Okay, this carbon atom is directly connected to the ring. Okay. Now, in this case, we have the ring will be the main chain because here, when we number it, 1, 2, we can number only 2 of them, right? So that means if we can number only 2 of them, that means the ring has become the straight chain, the root word. So in this case, so I number this as 1 dash and 2 dash. So at the first position, what do we have? 1-methyl. So see here both the attachment and the ring has 3 carbon atom, but we can, in the attachment, we can number only 2 of them. That is why we consider this as the substituent. So in the substituent, 1 at the first position, there is methyl. So 1-methyl. How many carbon atoms are there in total? 2 of them. Ethyl. We name the substituent. Now in the ring, how many carbon atoms are there? 3. So we name it as cyclopropane. Okay, students, the next one, if we see here, this is a ring, there are methyl groups attached, and this is carbon atom, and this is 2 valencies are satisfied, so 2 more. Okay, now we have to number it. Okay, if we number it, suppose if I'm giving this as number 1, 2, 3. Right, now I cannot give here number 3 because if you are writing the number on the ring, you should complete the ring. Okay, so 3. Okay, so here these are the substituents now. So these substituents are at 1, 1, and this is what substituent? Ethyl. Ethyl is at the second. Okay, now I draw it once again in order to number it in another way. This is, so I'm not writing the methyl groups now again. I just want to number it. So if here there's a substituent, I can give this also number 1, 2, and 3. Here let's check the substituent 1, 2, 2. So we have 1, 1, 2, and 1, 2, 2. If we check the first point of difference, this is same. But if you check here, the first point of difference, which I mentioned in my previous video, here, this is 1 and this is 2. Definitely, we will not go with this. We will check the first point of difference. So we will check this. We will use this numbering. Okay, I hope I'm clear. So we will not use this numbering. Okay, because we will use the first point of difference. Okay, I hope I'm clear. So according to this, we have at the second position, we have ethyl. And at the first position, we have 1, 1. Sorry. At the first position, we have dimethyl. Okay. So, or we say at the first position, we have 2 methyl groups. Now, while naming it, while writing down the name, we will follow the alphabetical order. So we have at the second position 2 ethyl, then 1, 1 dimethyl, cyclo, root word is propane. Okay. Cyclopropane. Now, again, moving on to the next one. If I'm giving you this question, okay. Here there's a carbon. Okay, this carbon is attached. So if I number it, 1, 2, 3, 4, or 1 dash, sorry. First choosing the main chain. Okay. So I'm giving you this question. So if you're choosing the root chain, definitely you will go with this because there are 6 carbon atom here. This has 6 carbon atom. But what about this? This has 1, 2, 3, 4. This is 1 carbon. This is another carbon. This is another carbon. There are 4 carbon atoms. So definitely this is the substituent. Right. So I'm numbering this as 1 because from this carbon, the attachment is made to the substituent. So 1, 2, 3, 4, 5, 6. I hope you understood why we considered this as the root chain because this has 6 carbon atom. So at the first position, here there's a carbon, okay, methyl group. Okay, so I'm making this as dash because this is the substituent. You can put it without dash also, no problem. So at the first position, what do we have? 2 dash methyl, 4 carbon atoms. So butyl, because it's a substituent, we use butyl, and then cyclo, root word is hexane. Okay. Similarly, if I give you another question like this, okay, so definitely here there is 6 carbon, here there is only 1 carbon, and with the carbon there is a substituent attached. So this is complex substituent. So this is our root word. Okay, now coming to numbering. This is number 1 because here the substituent is attached. 2, 3, 4, 5, 6. And This is what group? This is the cyclopropyl group. Now this is, I'm putting it as 1- because this is the substituent. So at the first position, what I have 1- cyclopropyl. And how many carbon atoms are there in the substituent? 1 carbon atom, methyl. Cyclo. What is the root word? Hexane. Cyclohexane. So this is how you number it. Or this is how you name it. Okay. Now moving on further. If I'm giving you a compound like this, carbon connected to 3-chlorine. So definitely this is our main chain or main root word 3, 4, 5, 6. And here only 1 carbon atom in the substituent. This is the substituent. This is the root chain. This is the substituent. So at the first position, what I have 1-, 1-, trichloro, only 1 carbon atom, methyl, not methane because it's a substituent. Then cyclo, what's the root word? Hexane. Okay, I hope I'm clear. There are 3 chlorine, that's why 1-, 1-, 1-. You can just write 1 also, no problem. You can ignore the dash. Okay, now coming to another example, CH2Br, CH2Cl. Okay, here I'm redrawing it again. CH2Br, CH2Cl. Okay, now here I can number it this way: 1, 2, 3, 4, 5, 6. I can also number it 1, 2, 3, 4, 5, 6. Both the ways I can number it. But here, check the first point of difference. 1, 2. Here also 1, 2. The first point of difference is the same. There is no other way. Okay, so there is no other alternative. In that case, we will go with alphabetical order. Remember, alphabetical order is your last option when the first point of difference you cannot use the sum of the positions. If you cannot use that, then only you will use the alphabetical order. So we'll not use this numbering, we'll go with this, where bromo is getting the first position. So at the first position we have, this is what? Bromomethyl, bromomethyl, bromomethyl. Then at the second position we have bromo, chloro. Sorry. I was talking about bromo and wrote bromo. Sorry. 2-chloromethyl. Then cyclo. What's the root word? Hexane. Okay. So please remember, students, alphabetical order is your last option when the first point difference cannot be used, when the sum of the positions cannot be used. Okay. Now, coming to another example. iodine, chlorine, bromine. This is one of the confused examples, okay, which it's easy, but students make mistake. So I'm redrawing it again, okay, so that I can number it in a different way and tell you. Okay. Now, this one. If we say 1, 2, 3, 4, 5, 6. Okay, here we are assuming that we go with the alphabetical order. So bromine, I'm giving number 1. Okay, 2, 3, 4, 5, 6. Okay. Because in this way, if I go in this direction also, chlorine is getting 4th number. Okay. Now, over here, if I'm using number 1, then number 2, 3, 4, 5, 6. Okay, let's check the positions. 1, 3, 4. In this case, 1, 2, 4. So I have 1, 3, 4. I also have 1, 2, 4. First point of difference, both are number 1. Next point of difference, this is 3, but this is 2. Definitely here itself, this we will not use because the first point of difference, this is 3 and this is 2. We will go with this. We will not be using this. Okay, so that's why I said alphabetical order is your last option. If we get the first point of difference, we will go with that. Okay, so this is not our numbering. This is our numbering. Okay, here, this is 2. This is 3. We will not be using this. So this numbering we will use, but while naming, we will use the alphabetical order. So at the 4th position, we have bromo. First position, we have chloro. Second position, we have iodo. Cyclo. What's the root word? Hexane. I hope I'm clear over here. Yes. So, students, I want to give you one homework. Okay, please give me the answer in the comments. Okay. Give me the answer in the comments. Okay, so this is your homework. Please give the answer in the comments.